Hey everybody, this is Larry. This is me doing week 4 of the weekly premium challenge. Hit the like button, the subscribe button, join me in Discord. Let me know what you think about today's problem. Today we have a premium hard problem, one that I haven't done yet. I doesn't seem like I have to solve thing on it. So yay, a new video, new problem kind of thing. Alright, let's take a look. We have 302 smallest rectangle enclosing black pixels. Okay, so you have a binary matrix. 0 is white, 1 is black. The blacks are connected and pixels are connected horizontally and vertically. Okay. Given two integers x and y that represent the location of one of the black pixels, return the area of the smallest rectangle that encloses all black pixels. You must write an algo that less than r times c. Okay. So it has to be axis aligned rectangle, I guess, which I don't know. Otherwise, it's a little weird. I don't know. I mean, honestly, this one reads a little bit not specified, but like we could. I think ultimately this is just a BFS, right? But BFS is going to be in the worst case O of m times n, so that's a little bit awkward. I don't know that there's any easy way about it. N is 100 from one component. Huh. That is interesting. Because how can you do better than linear time? I don't know that you could do better than linear time. Right? Because you have to look at the entire... I mean, you don't have to. But in the worst case, you do, right? Like, you can imagine a spiral thing. Like, if you do a spiral thing, then there's no way for you to you have to kind of look through it, right? Like you have to connect all of them, and as a result, but that spiral thing is going to be like n over 4 or something like that, or n over 2, n over 3, whatever it is, and that's going to be still linear. Huh. And I mean, I don't know that it's gonna be linear because there's less than linear number of cells. I mean, well, there's just linear number of cells. I guess that like the only reason why I hate to dismiss it is because maybe there's some algorithm where like, okay, well, if these are all the black cells, like it goes all the way to the top and bottom, then like then you know that you don't have to choose the ones on the right. But like I said, if you have a spiral, then it doesn't do it, right? I mean, I guess the hard part is not solving this, it's solving it in sublinear time. I don't know, how would you even, There's only one thing. I'm trying to think whether I don't know how to do it in sublinear time. That's wild. Huh. And I would also normally say that given that R and C is less than 100, like I would just do it linear time. But maybe that's trivial. Maybe that's not a, maybe there is a way to do it. Like, how can you sample in a way that's sublinear? I honestly don't know. How can you like if I had to guess, I would have guessed that the lower bound is m times n or linear, which is why I don't like. It's not even like I don't have ideas. It's that my idea is that this is impossible. And there's no greedy way about it because you might loop, right? I don't know. I mean, the one component thing doesn't really change anything. I don't. I'm not gonna lie. This is the only time that I might cheat. Only because not because I give up, but uh, because I don't trust Leetcode to be right. Um, Let me pause for a second. I'm gonna ask my chat room to if today's premium problem have a thing. I don't know, because and the answer is yes. Then I'll try a little bit harder. If not, then you know, I'll be right back. All right, I just went to the bathroom, and I'm told that there's a sublinear solution. That is not crazy. So I guess I have to think about it. Because I honestly did think that linear is the lower bound for this one. Okay, I don't know how to do this, but let's say, okay. Let's say this is one dimension, right? How would I do it? We have one dimension, we would just, I mean, this is just a binary search, right? We search upper bound, we search lower bound, right? Starting from the pixel, so yeah, we bisect the upper and the lower. And you do log n queries, right? And each of them costs 1, but if each of them costs n, I guess that's it. Wow, honestly, this one's pretty cool. It is not someone in the comments just gave a full spoiler almost on the complexity, which the video actually, but I got it just early enough to beat it, but now it confirms what I was thinking of. Sorry friends, if you're watching this live at home, it's a little bit awkward, my apologies. But honestly, I really did not think that this one has a sublinear thing, until like, unless you have like gun pointed to my head kind of thing, right? Which is what is happening now, in a sense that I was like, okay, well, all right, I'm going to draw some stuff here, right? Let's see. And actually, the solution feels very beautiful, but I wish I came up with it, you know, I wish I came up with it. Okay. I was going to copy and paste this, but this is not very useful. Oh, yeah, no, I did not put it up on the board. Yeah. So basically, yeah, right. But I don't think this is that useful. But okay, so then let's start over, right? So let's say we have a 1D array, right? Then what would that look like? So we have a 1D array. We have some portion that are black, right? I'm too lazy to throw it in, though. This is the technology. I guess there is a way I could throw it in without being so sketch, right? Like, right, close enough. You have to throw it in mentally. It is kind of fun, actually. Like popping those bubbles. Okay, in any case, right? And then you're given just one box, which maybe I'll mix up the color a little bit, right? So like one box, so you have something like this. So like this is one of the box, right? And then basically the idea here, given that, is very simple. You binary search to the left and to the right, right? And of course, when you do a binary search, this costs all of 1 because we look at whether the cell is black or not. But in a 2D array, and I guess that's the part that I should have came up with, or like more immediately anyway. So you have something like this, right? Then now a 2D array, you know, we would have something like I don't know, you get the idea, kind of thing, right? Okay, actually, it should not have fold out on top, but you can think of it as like you know, you map these. Okay, I drew this wrong. Pretend there's a gap. Okay, I could erase. I forget. Okay. Right. So now you have a 2D array, and you're just trying to map it to the 1D answer, and then the idea here is, of course, that ooh, what happened here? What is going on with my pointer thingy? Okay. Oh, sorry, friends. Technical difficulty. Okay. Right. You map it to these boxes, right? And of course, in this case, if only one of the thing is black, then that means that it maps to this thing, right? And of course, they have to be connected. So what I just drew is not possible. They have to be connected. And of course, yeah. And that's really it, I think. The reason is that now, instead of O of 1 per check, it's O of I want to say n, but it's not quite n. It depends on if you're doing rows or columns, right? So if you're doing rows, or you're binary searching on the row, then each cost is going to be the number of columns. So let's just say C, right? And because we do O of log n binary search, so it's going to be C of log R. Maybe I mixed this up actually. Yeah, I think I mixed this up. Sorry, friends. This is O of R because we're binary searching on one row, which has, and one row has C number of elements, right? So yeah, and we go down the number of rows, so that's going to be O of R, and typing is going to be O of R log C, right? And that's for doing the width. But without laws of generality, you can think about us doing the same thing for the height, but in the other direction, and we should be good. And the key thing to note is that we don't have to do the projection, the mapping, right? We don't have to do the mapping on the entire thing. Because, for example, let's say we have something like this as the graph, right? It may be that we could find, can find this here without even checking here, right? Because that's just how binary search works. Because you go here, oops, maybe you go here, and then you go to the left, and then you go back or something like that. But either way, you get the idea is that you don't check the entire search space, right? You only search some of them, and as a result, this should be the complex I said, which is O of R log C plus O of C log R. But this really fooled me. I don't know if I would have been able to do. I think, well, there are two things, right? One is honestly, Leetcode's been kind of crap lately. I mean, maybe that's an excuse. I don't know if it's a good one. I'll leave it up to you to decide. It's just that Leetcode's wrong on the problem statements enough that I'm not trusting it, right? So that's one. So that's why. I mean, I think if it was the other way around, where Leetcode problems are so steady, so not vague, so specific, that I always feel confident reading them and be like, oh, I understand this problem exactly, and that I trust that they did not make a mistake, then I would maybe try a little bit harder. But I didn't try that long because I was just waiting for someone to tell me whether there is a sublinear, like a real sublinear, and not just like, I don't know, them being dumb in something, which I don't know. They're not this time. I don't know about the other times, but yeah. Okay, so search for the width, right? We search for the width, so we know that we are. Which one is X? I always double check because sometimes I feel confused X and Y. It seems like X is the row, so we should be good, right? I'm trying to think whether I can do a lower bound thing. Like I feel like or not low. Like can I use bisect left or something? I don't know. But in any case, right? We can write this out. It's not that bad, right? So here maybe we do binary search, right? On the this is literally left. So search for the left edge. Yeah, let's search for the left edge, which is between 0 and x. And yeah, and first black, right? So here we have between 0 and x. If here now we have to get a column, right? I was still thinking about the first one. So if get column of mid is equal to, I don't know, just say black as a enum, right? So white is equal to 0, black is equal to 1, right? If get column equal to black, or has black maybe, I don't know. Yeah. So if it's equal to black, then what happens? Then we want to go to the left. We want to set right is equal to mid because it's a possible answer, and if it's not, then left is equal to mid plus 1, and that should be good. So now left is the left edge, which is kind of terrible, but okay. So yeah, so how would I write? Naming things is so hard. But yeah, with left is equal to left, say, right? And then here, I don't know, maybe we could have generalized this a little bit, but I want to keep it specific because I think the between x and c minus 1, first or last black, right? So left is equal to x, right is equal to c minus 1. So wow, so this part is the same, I guess. Or same, I mean it should be because it's binary search. So if get column of mid, if this is equal to black, that means that black is good. So we set left is equal to mid, and then else right is equal to mid minus 1, and we have to plus 1 to balance it out. And then this is the side, the with right is equal to left, and yeah. I know I'm not going over binary search in that much detail for this problem. Hope you understand. I still just want to make sure that I get this right. Before, I mean, I know I said, I mean, it feels right. It should be okay. I just need to get it right. Okay, now we search. Oh, I have to implement get car, right? Okay. C for column. Yeah, okay. If image of IC is equal to black, and we return black. Otherwise, because as long as there's one black, then it's good. For this problem, and now we search for bottom edge, and bottom edge is always going to be between 0 and y, right? And we want the first black. So 0, right is equal to y. Same thing. I can probably figure a way to, I don't know. Get row of mid if it is black. Also, actually, I messed this up because I wrote bottom, but technically this is top. Yeah, because I always count my fingies from the bottom up, but I know that's not quite what people mean. So so I have to be careful about it. Okay, so run the first black. That's between 0 and y. So that means that if this is black, then we want to try, yeah, we set right is equal to mid, right, because it is good, and we want to try something, a smaller number. So otherwise, yeah. And then we have height, top is equal to left, And then just one more. Search for bottom edge is between y and r minus 1, last black, right? Oops. It's just so easy to get into auto coding mode and then be wrong. Okay, we want the last black, so if get row of mid is equal to black, if this is a good one, then we want to try something bigger, so left is equal to mid. Otherwise, we have to go back up again, then we do a +1 for rounding reasons. And yeah, and height is equal to, or height bottom is equal to left, and then we can do height is equal to height bottom minus height top +1 because it's inclusive, and then we just return height times width, right? Hopefully this is right. Oh, I forgot to implement get row. Okay, I was halfway through. I was like, okay, I remember to write this, and then I just forgot. But you know, easy thing to fix, right? So for, did I mess this up? Do I need to get column? This doesn't make sense, right? Because this is for a different row. Oh no, that's right. So then now for get row, the column is constant, right? No. What am I saying? If you get a row, the row is constant. I am so dumb today. If what's it called? And that should be it, hopefully. So because you know how you sometimes feel like your eyes are tired? That's how I feel now. Okay, I mean, this is clearly wrong, but that's okay. You know, we can put, look, I got the one box right. But yeah, let's take a look. I mean, that's the problem with writing 4 binary searches instead of like some kind of abstraction thing, is that who knows? It's easy to mess up. Yeah, and you don't know which one's which. Did I mess up the why? Okay. So we have height and 2. Y is 2. Should be the 0, 2 one, right? So 0 to 2. So this is okay. So we get the row and it's black. Then we try to see if we can get bigger. Otherwise, if it's right, then we get the next one. Now this should be right. Why is height top 2? It's either that or my get row is wrong, which is entirely possible. Get 2. I mean, this feels right. I mean, this is definitely wrong because height top should not be 2. But I don't know why. I guess I don't know. No binary search. Height top 0, 2. Okay, and that's the only loop it does. That doesn't make sense, because then it should not be 2, right? Like after the loop. Do I use some? Because this should not jump by 2, which is why this is correct. So that means that I'm doing something else wrong. It feels like left, like mid is 1, and then it goes to, but it's black, right? So okay, so that just means get row of mid is wrong, despite my efforts. Get row image. Oh, I see. Okay, Because the reason is that this is a one string and not a one number, where my E number is a one number. So I just have to convert it, that's all. But that's a very, I don't know, very Leetcode thing to do. Okay. I mean, at least now we're wrong in the other direction, which is maybe better. I don't know. Probably not better, but it is different. Okay, 0, 2, whatever, 0, 1. All right. Okay, 2, 0. That's right. I guess we have to do the with left, with right. Oh, did I mess up the left and the right? Where's my with? No, that looks okay. Maybe. Let's see. 0, 3, 0, 2. Oh, no, 2, Z. Wait, what? Yeah, 0, 2. Oh, with right should be a 1. So that is wrong. Maybe? Get column, okay. Just want to double check. I feel like. Okay. My eyes are so tired from the allergies. Okay, so 2 and 0. This one should be 0 and, oh no, 1 and 2. So with left. I mean, at least the idea it seems pretty right. It's just that I am clearly dumb. Let's move this closer to here. X is on the row. Did I confuse the X and Y? That's what I'm trying to think. X is on the row. So we're going left to right, right? So X, why would it be an X? X doesn't make sense. That's what I'm trying to think. Did I confuse them? Maybe I did. Because, okay, so you get a riff, then the Y would be the Y, right? Yeah, because you have the left and the right. Okay, I think I confused the X and the Y. Even though I tried to pay attention to it. So, and that's fine, maybe. It's a very easy mistake to make. And there you go. So let's give it a spin. Hey, sublinear time. And yeah, so what's the complexity, right? We kind of talked about it a little bit. The two binary search. But yeah, it's going to be O of R log C plus, well, I guess plus is in the inside we want. And that's basically it, right? Because for the row, you do, for the riff, we do log C number of iterations, each of them causing O of R time, and then the same but opposite for C log R. And that's it. That's all I have with this one. I mean, I don't know. I would go over the code more, but it's just 4 binary searches. I don't think it's super interesting. But definitely, I mean, easy to make mistake, as you saw. Yeah. And my eyes are killing me. Allergies, and I didn't sleep well. So I'm going to go to bed. Thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye-bye.